So instead of saying what is the sine of pi over 2 and getting root 2 over 2, or I'm sorry, of pi over 4 and getting root 2 over 2, we're going to say what angle has the sine of root 2 over 2. So you're working backwards. You're working backwards out of that. What angle or instead of angle, I should write what theta. So what we're going to start to think about here is more along the lines of where is sine positive? Because my answer here is positive. So think about when you're looking at the quadrants. Where is sine positive? Sine's positive there. You're thinking cosine. All right. Sine's going to be positive between those two quadrants. Where is cosine? Cosine is positive between 1 and 4. Right. Now, what this is going to, we'll get to tangent here in a second. What this is going to allow us to be able to do is when we're talking about sines, cosines, tangents, if you're talking about the positive value, you're going to look for the sine value in quadrant 1. If you're talking about a negative sine value, negative root 2 over 2, you're going to get the value in quadrant 4. That's how the angles are going to work. So what happens here is you're still going to use that idea of a reference angle. That gave us the root 2 over 2 here for the sine value. But if I asked you what is the negative root 2 over 2, oops, it would have been down here at negative root 2 over 2. In that case, we'd say it would be negative pi over. Yes, sir.
So this is a little off, but sine is like kind of abstract, but I'm wondering, how would somebody invent this?
It's the ratio of the sides. The ratios of the sides when you're talking about right trigonometry. And that's where it all came from. They noticed that there was the same ratio pattern that occurs with the sides of angles to the angle measurement. This was thousands of years ago. This is what people did. Without cutting them. Yeah, this is what they did for fun. Okay?
Well, there's got to be something.
There's got to be something going on, right? Cosines, when you're talking about positive, negative, go ahead.
So doesn't that mean there'd be two answers for each, like, sine value?
It's going to depend upon if the, if it's going to say the inverse sine of pi over 2, you're looking for the positive answer. Inverse sine of negative pi over 2, you give me the negative answer. You're only looking at it within one, those two quadrants. So. When we get into this, is what Lance was talking about yesterday. When we start talking about solving equations, when we get to solving the equation portion, that's when we're going to have multiple answers. Today we're just looking for the angle. When we get to the equation, we're going to be looping around more often than not. You could loop around infinitely number of times where your sine of 45, your pi over 2 or pi over 4, has a sine of root 2 over 2. And what happens is this root 2 over 2 occurs here, and it occurs here. Do we agree?
Yeah.
So if I had the root 2 over 2 here, and this is 3 pi over 4. What happens is every time I rotate around the circle, what did I do to get to there again? Plus 2 pi. So what happens is this would your solution if there's no parameter, and we're not at this point yet, guys, so don't worry about this for today. What will happen is when we start talking about that duplicate answer, is if it doesn't say within one rotation, it'll say find your solution between 0 and 2 pi. If it says find a general solution, your general solution would be, well, this point occurs every 2 pi r. Every time you go around, however many times you go around. Or 2 pi n, excuse me, say that. Same thing here. This would be 3 pi over 4 plus 2 pi n. There are instances where it occurs at pi intervals, with a diagonal like that, so you'd say plus pi n. We're going to get to that point eventually. Those are the types of problems that look a little bit different. That's more chapter 14. And that's kind of, I know that's what you're saying, you're going to get those values as you rotate around.
So we're only gonna look for the one.
Yes, today we're only looking for one. Okay, and you're looking for one within these certain parameters. Cosine you're looking for between 1 and 2, because you have a positive and a negative. And then, wrong way. And then tangent you're also looking between 1 and 4, because your positives and negatives. Remember, tangent is undefined on the vertical axis, or vertical y-axis, excuse me, because when you divide that out, you have it's y over x. If x is 0, you get an undefined solution. That's where we got that asymptote. I think you were asking about how the graph of tangent looks. Yeah. That's why you get those dotted lines there at the zeros. Okay. So let me show you how this looks like. What happens here is, if I want to say, what is the inverse sine of root 3 over 2? If I wanted to say, what is the inverse sine of root 3 over 2, that basically is asking me what angle has a sine value that is equal to the square root of root 3 over 2. Now, when I see root 3 over 2, what triangle am I working with?
30, 60, 90.
Very good. I'm working with the 30, 60, 90 triangle. Now, also, I'm working with a positive root 3 over 2, so what quadrant will we be in? The first one. We'll be working in the first quadrant. If it was negative, then my sine values, I'd be looking at it in the fourth quadrant. Okay, we're working off there. So again, what I'm going to do is base this kind of off the triangles that we were drawing yesterday.
It's a 60-degree triangle. I mean, 60 degrees.
Correct. Everybody see that 60 degrees has a sine value of the square root of 3 over 2?
Yes.
So the degree answer would be 60 degrees. Or in radians, what is 60 degrees? Very good. Again, the whole basic idea of this is still stemming from being able to use that right triangle that we were drawing up yesterday, those 30, 60, 90, 45, 45, 90, to solve those other answers. Now we're just working backwards, recognizing what this value is in here to what triangle it matches up with.
Are we just doing this?
Yes, again.
Harder than this?
Not really. Not really. When we get a little bit more complex than this is when you have to reintroduce the calculator. And you guys have done all of that before. You did that in geometry. You had a right triangle and you had side lengths of 8 and 9 and you had to know what theta was. How would you find theta? Inverse cosine, and you would have to use your calculator for that because it is not a special right triangle. Those are easy. You press buttons. Okay? These are the ones you have to kind of work yourself through. So let's take a look at these two. Inverse cosine of 2. Inverse cosine of 2. What angle is going to give me a cosine of 2? Think about your unit circle. What is the largest value of your radius always on the unit circle? 1. Can I have a cosine of 2? No. Doesn't work.
You'd have to have a secant.
Yeah, that's the only way.
Correct.
Yeah, that's what I was.
Yeah.
Yeah, that's how I was.
Yeah, and that's good. I'm glad you were thinking that way. What these guys over here were saying is, if it was the inverse secant, you could go that your 1/2 star. But in this case here, again, guys, everybody see how whenever you're dealing with the unit circle, the basic idea here is that it's never your radius is always 1. You're not going to get a 2 for an answer. It's an undefined answer. It doesn't work. There is none. Okay. Tangent, -1. If I'm tangent of -1, you remember the trick with tangents when they were equal to 1 or -1? What triangle was it?
They're 45.
It was 45s, right? Tangents were 45s. because those were the same.
Fourth one.
And it's fourth quadrant because tangents, we're looking for tangents in first or fourth.
So it would be.
What's the degree measure there? Negative 45 or? We'll use the negative.
Negative 7.
Whatever, 45.
Negative pi over 4.
Or no,
Alright,
negative-
for you. So this, because this one's down in here, so you're going to use we're going downward, negative 45 degrees.
Like, why did you look for the quadrant two? Tangent, negative quadrant.
When you're working with these things, when we're doing the inverse, they set it up a little bit differently. The quadrants you're going to look for stuff is in cosine. Cosine's always going to be between 1 and 2. Sine is always going to be between 1 and 4. And tangents are also 1 and 4.
So do you put the answer in radians or degrees?
Both.
Oh.
Yeah, you do one of each. That's what they'll ask you to do it. They'll write it in degrees, write it in radians. Yes, sir.
Why are tangents Is this one a positive?
Negative. There's one quick positive and negative. Because what happens through a tangent, if I'm crossing from positive to negative, or so if I'm going from 0 to 180 degrees, bless you, isn't there a break where tangent is undefined?
Oh, that makes sense.
It's broken at the 90 degrees because that's an undefined value. So what they're doing is that they're using the reference coming back down to the fourth quadrant to alleviate, to be able to maintain and have a full set of values aside from 0 and 27. Does that make more sense? It's a very good question. Yeah.
Earlier it said in the notes, it said the sign was the.
Oh, I was just saying sine was positive going this direction. I was showing you here, this is how you get a positive, the quick positive and negative. I was just saying where is sine positive.
Oh, okay.
I was just reviewing that real quick. Yeah, I did. So, sorry. I'll just take a look at the screen. What's that? Glad I can help you. You're welcome.
So,
Let's try another one. We'll try a couple of these. I'm only going to give you a few of these to try over the weekend. These can get a little, they can get messy, but if you understand which triangle they're built out of, you're going to be okay. And I see you're visualizing. Try it. It's easier.
the first one is the 60.
Inverse tangent of the square root of 3. Which triangle is that going to be?
30, 60, 90.
Okay? So just quickly draw a 30, 60, 90. Which one of those is going to give you opposite over adjacent of root 3 of the 60-degree angle? Now, this value is positive, correct? So I'm looking at a 60-degree angle, or what's it in radians? Very good.
Oh, I remembered my question.
Yes, sir.
So, you know how for number C on the last page,
Yes.
how like you wrote the answer negative 45? Why wouldn't you say
Because what you're looking at is you're just bouncing between. There's a parameter that you use too high and negative.
so? Around.
Yeah. Again, one quick reminder. For cosine, you're going to be between 0 and pi over 2, and negative pi over 2. Same thing here. Those are what you're looking at. Cosine of root 2 over 2. We should know this off the top of our head. What is it?
45.
Very good. What is that in radians? See what happens by taking all that time through the unit circle stuff on 13.3, how much easier this is? Yay! Thank you for the enthusiasm. Sine of 1/2.
That's
30. Very good. Pi over 6.
Can we just look at this chart? Is that
Well, you won't have that chart on the test. When do you have to do this?
Wait, is this gonna be like?
There'll be calculators?
Like 13.1 to 5.
Probably not. Probably not. It'll probably just be this stuff. And then what about the inverse cosine of negative 1/2?
negative 60 or negative 5.
Not so scary, is it?
Blue items matter.
Wait, but is cosine x,
Yes.
does that matter in this?
A little, yeah. Yes, sir.
Why did the inverse cosine of 2 not work?
The inverse cosine of 2, because you're looking at it within the way that the revolution of cosine, and I think I skipped over how, I kind of went over that kind of quickly here. Your answers are always going to be between -1 and 1. The inverse has to be between -1 and 1. Your radius of the circle doesn't grow any larger than 1. So your biggest value on the circles are always 1. Because you can always simplify it out, and you can always get a lot. Does that make sense? Let me give you just a few of these to try out for tonight. I don't want to, like I said, I don't want to go too crazy on this. We'll jump into the rest of the stuff next week. I think we've done a lot of work this week. So this is on 13.4.
How about we take the night off?
How about we don't?
How about,
Hey, you can take tonight off. You can do this over the weekend. It doesn't matter to me.
wow. How much time do you have left?
I don't know.
10 minutes.
So this is on what? This is page 795. Page 795, there are 8 of them. So 795, 18 through 25. I believe it says give an answer in degree and an answer in radians, please. Remember, there are the quick little parameter of that. Yes, sir. Of -1/2? All right, so you're at -1/2 means you're at 30, 60, 90. So the inverse sine of that has to go out to the 30 degree, but it's negative, so you have to, it's a -30 degree or negative pi over 6. I thought you said sine of, oh, I'm sorry, I misheard you. The inverse cosine goes with the 60. I apologize. I thought you said 30. So yeah, it would have to be, and it was a -1/2. So that means it's a 60-degree angle, but it's negative, so it's -60 or negative pi over 3.